Alright. These are the tools that I would use to remove a quad flat pack. We have flat tweezers, we have angled tweezers, some dental picks of assorted sizes. The other tools you would want is flux. This is a more of a fluid flux. It's not as viscous as the other type of flux that I'm looking for right now. Where is it? The other is a standard Kester 186. Where is it? Come on. You'll probably have this problem too. Anyone who doesn't have this problem with finding things hasn't been working. That's the way I see it. If you have a clean desk, that means you haven't been doing anything. Because you have nothing better to do than clean. I have work to do, so I don't have time to do that shit. Where the fuck is it? Right here in front of me, of course. That's one quality. Anyway, this Kester 186 is very common. It's also really sometimes difficult to clean off the board. So whenever I'm removing something and I don't care about having to clean it up, I would use this. However, if I'm caring about the board and I'm applying something, sometimes I'll use either one. But the main reason is you have to clean this up. You have to clean this off the board because it just looks cleaner, and you can actually it makes it easier so you can visually inspect the component and your craftsmanship and your work. We are using eutectic solder. This is a 6337, and I'd like to use the flux to go inside the blunt tip needle here into the flux, because sometimes we get a bottleneck when the flux settles in the syringe. Another thing I'll do is actually pull the plunger back up and squeeze and apply pressure to the plunger to get things going. And I'll always use like a test point. You can see some of that coming out. So what I would want to do, what I typically do, is flux the component, the leads, and you can be generous with it. Just don't overdo it. You know, just enough to get things done. And we should be able to see what I'm talking about here. It's pretty much what you would say if you were sitting right here. Now, typically we're in a hurry to get things done. But that doesn't mean you can't take the time to perform your work safely or with the precision and accuracy, because there is a difference between precision and accuracy. We'll get into that in another time. However, I prefer accuracy over precision, because you can have precision and be completely off the mark. For instance, have you ever been to a carnival and you say, "Hey, guess my age," and they'll intentionally have someone who looks considerably older or sometimes younger, just to throw them off. And you might have a cluster of individuals that say, "Oh, this individual looks 30 years old," where in reality he's more 50. That is a description of precision. So you can have a cluster of, "Oh, he looks 30, but he's actually 50." Even though they're clustered, that doesn't mean it's accurate. Accurate means you're dead on at 58, at the age of 50 years. Okay? So there's a quick definition of accuracy versus precision. You can shoot for both, but if you're going to pick one of the two, go for accuracy, because precision, you can be way off. Now, we have our component fluxed. It doesn't matter if it's sitting there for 2 seconds or 5 minutes, but you would prefer to do it well. If you're applying it, you should be doing it. You should be doing the procedure within 5 minutes. And if not, you should remove it, and I would remove it and then start over. As far as the hot air reflow, temperature and the particular device used, I could care less whether the device is digital or analog. I could care less. I want to set it to a setting that I know, that I have an experience with it, that this is the size, this is the temperature, this is the height that I typically use. And once I have it, I memorize those dials. I could care less what the temperature is, because it doesn't matter. I just find something that works and you stick with it. That's it. You don't have to deal with all that. Oh, it's 200 degrees. No, it doesn't matter, because the distance is going to change so drastically. You can't measure it. It's bullshit. So whatever this is measuring at 2 inches is going to be way different at 4. So find a distance that works for you, a working distance, for a particular temperature setting that you find that works. And you can only do that by experimentation. And that's fine. And that's exactly what this board is. It is experiment. And we're going to get this back set up. This is in no way well, what is this? Okay, I have this set up. I have it set for 400, and we're climbing. We should be hit. And I have a preference of the number 4 as far as airspeed. This is going to vary from device to device, from digital to analog. I could care less. It doesn't matter. If it gets the job done, that's what matters. Now, here's what we want. I like an angle. And you can see the flux moving around. What we're doing is we're kind of soaking the component. When you're experimenting, it's important to take the time to actually think your procedures through and to kind of get the whole procedure done before you do it. So as if you're driving a car and you see a turn coming up, you would want to prepare yourself to make that turn and to visually check to see if there's any oncoming cars, any cars that may be passing. So in other words, you want to see what's going to happen in the future before it's already done. And you want to do this here. You don't want to push too hard on this component and possibly bend the leads. If you're trying to recover the component, yeah, you don't want to bend the leads. But if you're trying to discard the component, that's fine. You don't care if you bend the leads, but you don't want to break the pads on the board. Yeah, that's a major thing. We can play around. I like to, again, I have, the experience and the touch and feel of knowing when and knowing how much pressure to apply on this corner here. Now I'm going to turn the heat up a little bit. Actually, what I might do, now I don't care about the components on this board, so if I did, I would tape off the surrounding components with kapton tape. I typically use a 1/4 inch tape. I won't demonstrate that, but you can imagine how to do that. If you can apply tape before ever in your life, you can do it to a board. It doesn't have to be, it just needs to, it's a shield, and that's all it is. Now you can see I'm taking my sweet time with this. I'm actually going to apply some flux, or some more solder here. There we go. And you're allowed to do this. This is fine. Want to be careful of that. Did you see that? I got a solder ball and I just did that. I want to get rid of that. Yeah, that was an asshole thing to do. I'm actually going to turn the air up a little bit. No, I'm maxed out. I'm just going to be more patient with it. If you think you might be screwing up, don't be afraid to get away from it. And this can go for anything. Don't be afraid to get away from it. Take a walk. Breathe. Think it over. Yeah. Boy, I'm just building solder balls today, aren't I? It should be any second. I can feel it. And don't rush it. Don't rush it. It's a large component. It has a large ground plane that's absorbing a lot of this heat. You can feel it, it's coming up. Now this is just a demonstration of how I would do this, how I would apply the steps I need to remove this component without damaging it. Because I've been really patient and this thing hasn't budged, I'm starting up. I'm starting to wonder, has it been glued to the board? It's very possible with components like this. I'm applying light pressure on the tweezers, and I'm trying to concentrate on what I'm doing while I'm talking. And I have the phone ringing. And at this point I'm deciding whether or not I should answer the phone or continue my process, because I would have to heat this all up all over again. So this phone's gonna ring. Come on. Yeah, and I don't care. You can see all these leads are molten. Now, why it's not moving is probably because we have something. This thing might be glued down. Son of a bitch. Or it's got a significant attachment to the board here. Man, that is cooking my finger. Wow. Oh my. Oh my, baby. Wow. Come on. Damn. Oh. You gotta be kidding me. Huh. Will they glue it down? Fucking assholes. I can see it trying to lift. I can feel it. It just doesn't want to budge. And I just dropped the flux on the ground. Okay, I'm starting to get nervous about this component. If I applied too much heat that I've damaged it, it looks like the solder is getting bored of being there and being overheated. Jesus. There's no way this is taking this long. It tells me this has been glued or epoxy to the board for the manufacturing process. I'm determining that from experience. Now, one way you can tell is by looking at the opposite side of the board to see if there's a bunch of thermal vias. This is unreal. How is this chip? There we go. Wow. Yep, and there's our thermal via. Wow. Now let's inspect some of this. That is going to be very hot. Now again, we were maintaining that we are trying to keep the chip alive. So what I want to do is okay. So, I'm inspecting the leads by eye here. They all look perfect. There's a few solder bridges that I can see, and that can be taken care of with a solder wick. To clean the board, what I would do, you can heat that, we'll remove that. Again, the same thing. It'll be another day, because I'm going to take a break. So what I would do now is change the temperature. Now we drop it down to 100. That's the minimum that this will do. Or you put it back in the cradle, where it will turn off the heater but maintain airflow. It's important to do that because you can overheat your heating coil because the airflow is off, which means the coil keeps staying hot and there's no airflow to keep it cool. That is bad. So if anything, you want the fan to stay on all the time. In other words, and you could also hear it, which is an audible indication that you have a device working or a tool on. Okay. It doesn't keep it to a safe temperature. It's just low, and it will maintain the life of the thermal coil. Okay, so there's that. It's removing a quad flat pack with a thermal pad. All right, let's see it here. Come on, focus. It doesn't matter. You get the idea. That's the process. That's what I would want you to do. If I was showing someone how to do this, that's how I would want it done. Take your time. Take your time. Add solder, add flux. If you get frustrated, walk away from it. Don't go around adjusting temperatures unless you're experimenting. But I know from experience the distance, the time that it typically takes, and the temperature that I typically use for this particular heating iron, or for this airflow tool, right? And that's important. So I'm going to turn this off and turn the video off. There's that.